Hello people, and we're back with a topic that you like, you adore, and yeah, let's be honest, you don't want us to film any new videos about racing, but we still want to finish this topic because it's complex and it's important. So what are the finishing touches today? We are discussing URLs, callbacks.
Well, it's not really callbacks, it's more like, well, the thing is that when you start working in Defold, you need to figure out how addressing works, and it's kind of simple to just, like, for example, if I want to send a message to a particular game object or a particular component, I just type the name and use the hash to separate the game object part from the component part. But there is something that you will encounter after a while that is called a URL that might raise some questions with you. Like, what are those? Like, how are they different from the regular strings?
In previous videos, we kind of discussed like how to construct the address.
Yeah.
So what is the difference between, well, the constructed address that we have discussed already and the URL?
Yeah. Well, there isn't any difference from the engine standpoint, but from a user standpoint, they look different, but they are sort of the same. So let's look at an example. If I have some code that reacts to a message that I have invented that I called activate. So let's just recap how to, if I on reload here from that I have on the astronaut, let's send a message to that particular gem. We can do that by posting, and we need to find the address, and then we need to send it activate. So this is pretty standard stuff.
Yes, and you watched that in the previous videos.
Yeah, exactly. So
you know what we're doing.
Yeah, it's in level collection, and there it is. That is a gem. So the only thing we need to do here is to type level/gem. And in this case, since we are in the root of the main collection, we can use a relative address like this, or an absolute address. It doesn't really matter. And when we reload this, why don't I get the... Oh, sorry, I should... So I can send it this message, and whenever I hit reload here, this function is called, and another message is sent to the gem. And this is a string that makes out the address of this of the script component in.
And you're not hashing it.
I'm not hashing it because the thing is that in this position of this function, I can actually type a number of things. I can type a string like I'm doing now. I can also type a hash. If I want to address the specific game object, I can do that. Then I do it, I write, I have to have an absolute address then, and then I can do it again, and let's just restart it so I can see that it arrives properly.
Any speed performance difference from the engine side?
No, not really. What happens is that if I don't hash it here, the engine will hash it for me. What I cannot do though, and this is why I cannot do this. I cannot type the full address to the script in this hash, and that is because the hash. Well, we need to go back a couple of steps and see what actually happens here, because what we type here will get translated not into a hashed value but into a URL, which is a compound value. That is a multi-part thing.
And that is the topic of our video today.
Exactly. So let's look at what we get here, because you see this little. Let's look at what the sender of this message is. So when it arrives, let's just print. We see that every message that is sent arrives at the target, and a sender parameter is tagged along here. Let's print that and see what
who is the sender.
Who is the sender? So let's reload this script and then go back and reload again and send another message. And we see that the sender here is a URL. And this looks a little bit funky, maybe, if you haven't seen it before. The URL consists of a number of elements. You see, first it says, let's type it out here. We have main : / and then we have astronaut.
An astronaut component.
Yeah.
Which is a script, I assume.
Exactly. We can just double check that. Because if we see here, we have the astronaut, and the script component is that one, and it's called astronaut. So that is the one that is sending the message, right? And it's all, so it's astronaut here. So this is the full URL, and it consists of a couple of parts. We have this part, which we haven't talked anything about. Then we have this part.
And we know about it.
Yeah, and we have this part
that
we also know about. And when we type a string into a message post here, for example, we can type a full URL or a partial URL. And what we're doing here when we write this is that we're typing a partial URL. And this is going to be translated into an URL object.
URL object.
Yeah, and we can construct a
now
URL.
this suddenly is an object.
Yes. Well, an object, it's sort of, it's an object in the same sense that vector, vector 3 is an object. So it's just it's a value that is that consists of 3 different parts. And we can deconstruct that value. So let's do that here in JavaScript. We saw that it's a URL. So sender is a URL object, and we can print. It has a couple of different parts. So we have a socket part. Let's send the message, and that socket part is called main. So we know that this is called socket, and this is a URL. And this is actually the same type of information that is in a regular URL that you write on the internet. And in that, this is also called socket there. Usually you see something like HTTP or FTP or something here. But in default, this is used differently. So that is the socket part. Let's look at the other. We can also find there are 3 parts. The second part is called path, and the last part is called fragment. So let's send the message again. There you go. So the /astronaut is the path here. This is, and then the last part is called just astronaut, which is the fragment here.
This is very cool. I'm still trying to assemble together the knowledge in like hash versus string, socket, path, fragment. It's like,
yeah. If you look closely, you see that all these 3 elements in the URL are hashed values. So those are 3 hashed strings,
right?
And that's what a URL
when you
is.
print component,
yeah,
they hashed values.
So so these correspond to different things. So this is the world part. We haven't talked a lot about what we have.
Video number 1.
Yeah, video number 1.
World is in video number 1.
Yeah. And path, this is the game object.
that's video number 2. No, number 3. And that's fragment is video number 2.
A fragment.
Probably. Maybe I messed up.
Yeah, this
Watch all of them once again. They are cool.
Yeah.
I mean, we're so proud of that video.
Yeah. And fragment, that's the component.
Mm-hmm.
So let's say that we can construct these URLs manually if we want to. Let's say that we want to send the activate message to instead of writing a string here, let's call gem URL, and then let's construct that URL here.
But any real life use cases, why would we want to construct URLs? Is it like when we want to do something dynamic on the runtime, or?
Well, yeah, we're going to get to. There are some use cases. It's not super common, but there are some cases where you have to do this. So one way of constructing a URL is just typing a partial URL or full URL. We can write main. Where did it go? Level. It was called like level, and then gem. Okay, so we can construct the URL ourselves if you want to, either implicitly by typing it here, like we did before, just type a string, but we can also create with a msg.url constructor. We can construct the URL, and then we have the URL object here, and just use
URL object, meaning that's going to be a hash, not just a constructed string.
It's going to be a compound of 3 hashes: the socket, the path, and the fragment part.
Like a table, or is it like?
It's not a table. It's
not a Lua object. It's a C object then.
It is it's a user object in Lua lingo. So it's not a built-in Lua object. It's like a vector 3 is a similar type of object. That is it's a compound of 3 different floating point numbers. Here is 3 different hashed strings, and we can type this in a number of ways. We can separate the different parts as well, and type like first we have main, and then we have gem, and then we have gem was the. So I can type it like this. So I have the socket part or the world part first. I have the path to the game object secondly, and I have the component part, the fragment, last.
So for those who forgot, like the world/socket, that's the root collection.
Yeah, exactly. The root collection that is loaded at startup, or you can load yourself different worlds with the collection proxies if you want to.
Video one once again.
Right. So we can construct URLs and we can deconstruct URLs. We did that on the receiving end.
I still can't wait. Why would we want to do this exercises?
Let's say, for example, that when this gem gets the activate message, it should do something with on the astronaut sprite. So what we get back here is you get on the sender object is a URL, and we printed the different part. We know that it's main astronaut, which is the script. But we're not into. So what we can do here is, let's say that what we want to do
is to get astronaut infected after the animation is played on the game, for example.
Or let's just deactivate the sprite just to get some.
Can we color it red? I want infected astronaut.
Okay. Yeah, we can do that, but I think it's going to be simpler just to let's post. And we're gonna post to sender, and we are gonna send it disable. And this is not gonna work for obvious reasons, because sender is not the sprite. We already seen that. That is the script component.
Yes.
So we need to change this somehow, and how can we do that? Because this is not a string, so we can't do string manipulation on it. It's a compound of 3 different hashes. So what we're going to change is the last part. So we know it's the fragment part needs to be different. Right now it's it's actually the
Right now it's a script, and we need
and we
sprite.
need to change it to sprite, and the sprite's name is, let's see, we need to figure that out. So we have the astronaut here, and the sprite is called, oh, sprite, that's easy. So let's do that.
Yeah.
And then save it, reload that, and then try to send us message again and see if it works. Oh, plop, it disappeared. So this is one of the reasons why you would want to manipulate URLs, and it's important in some cases to understand how to do that. It's when you have something, you have an address or an URL that points to a specific game object, for example, and you need to change some part of that.
So the use case that I see now is basically like, say I want to send the message back to the astronaut again, like I still want him get infected, but I want him to get infected as in like the suit is like changes color, say to red or whatever, only after the animation on the gem has played, because it makes sense during the gameplay, right? Like the astronaut hits the gem plays animation or something, and then the astronaut's look changes, maybe the skin changes, something. Like, how do we wait for the animation to get played and send the message back?
The thing is that when I send this message and starts playing an animation, this game object that contains this sprite will get the message when it's finished. The gem animation is a ping pong loop animation, so it will not finish. It will never finish.
It will never finish.
Yeah. So let's change it to once forward. Let's go back. And let's do it like this. So now the gem script, I print the message ID for all the messages I get, and then let's send it a message. We say get activate and animation done. So the gem script gets an animation done here. So I can just.
And who is the sender of animation done?
Let's find out.
Since like it's obvious who sends the activate message, but who is the sender of animation done? And like after animation done arrives, the sender I assume is different, and then you're talking back to the sender trying to change the sender sprite, and it's not the astronaut. So you somehow have to cache the astronaut sender, or just know that that's the astronaut and explicitly.
It's actually the sprite itself that sends that. So we cannot use sender in that case. So let's say that we wanna. Oh, I need to
return.
I need to enable this guy. Let's just restart it.
Yeah.
So let's remove that, and let's say that we want to. When the animation is done, we should change the sprite. Okay, and we cannot use the sender here. So what we can do then is to just store the sender here.
And it would be within the onMessage function of this object, right? Self-sender variable.
Yeah. Self is the script, the current script instance. So we can store things in that. So this will live in the game, in that game object component for the lifetime of it. So as soon as it gets the activate message, it stores the sender, and then we can use the sender here. So we can change self-sender fragment and then use self-sender here instead. So let's run that, and let's see how
do we still have the prints, so we see the sequence of events?
Let's do that.
Yeah,
actually, it's good. It happens so quick. So let's print activate arrives. Animation starts. Oops, and then There you go.
Mhm.
And that is when the spread should be disabled.
Now let's walk through this once again.
Right. So let's go back to the astronaut script. Send the message.
Yeah.
Okay.
Right.
There you go. Activate arrives, animation starts, animation ends, and it's gone.
So it works as
Yeah.
designed.
It works as
We cache the sender, and then we
Mhm.
utilize the sender to do something with it.
Yeah, exactly. And that is pretty much it. So in 95 or more percent of the cases, you never need to construct URL objects or deconstruct them for that matter. It's just a matter of, okay, you address with strings or hashes. But it's very good to know that these are the compound objects that Defold uses under the hood, and they are three parts. So they have the socket, which is the game world. You have the path, which is the full name. In the astronaut case, it's /astronaut. In the gem case, it's /level gem. Like that, and then you have the fragment part, which is the component.
Let's remind people why it's level jam, because astronaut is in the root collection and jam is in the level collection, right?
Exactly. So it's just a name. It's important to remember that. So level in the root of here's the main collection. Sorry. So in the root we have the astronaut game object here, and there's also another collection within the main collection. That's
and there's
level.
The jam.
And if we open that up, you see that here's the jam.
So with that, do we consider the addressing topic covered fully and explicitly, or do we still have any secrets from them?
Don't think there is anything else to talk about, actually. There might be specific use cases that people have questions about how to solve this or that, and feel free to ask, and we can see if we can.
I look into them and they're like, no more addressing videos.
Nope.
But then we finished with addressing. And we'll be back with videos about GUI and maybe camera. We'll see what we do and what we have the mood for next week. And see you next week. Goodbye.
Cheers.
And goodbye addressing. So Mika, we have a problem. People actually don't want any more new videos about addressing.
They don't?
No.
Why not?
Because now they want videos about UI, GUI, and cameras. But I guess we'll still do the video about addressing for them.
I didn't know that they want to have videos about GUIs and UIs.
Well, I mean, we need to finish the addressing topic anyway.
Yeah, I think we should do that and do the thing that people want later on.